Greetings and welcome to another math video presented by Mr. Nagengast. Section 5.4 of Pre-Calc, Sum and Difference Formula. So we're going to look at, well, that's pretty cool. Try this again. We're looking at the sum and difference formula. Now, looking at the sum and difference formula, many of you had picked up the sheet from me this afternoon. If you did not, please pause the video. You can write these or jot these down. And even those that do have it, it might behoove you to jot or write these down and sort of start to commit them to memory, or at least get a feel for how they are presented and how they work. At any rate, looking at the sum and difference formulas, if you are back with us because you had paused or you are just still working with us, the sum and difference formulas are used to give exact values at times. Now we know that we can put cosine -1 or the arc cosine of 75 degrees to come up with some value, a decimal approximation. But if we look for an exact value, we are really thinking of our trig chart. Now you remember we had 30-degree angles, we had 45-degree angles, and 60-degree angles, as well as 0 and 90, but we're not really looking at those angles for this activity. You also recall that 30 degrees was pi over 6, 45 is pi over 4, and our 60 degree is pi over 3. Now these are in radians. Now taking a look at this first problem here, we look at it and say, well, how could we get 30, 45, 60 to become a sum of 75? And the answer may be painfully obvious to some of you or some of us, but sometimes it doesn't always work that way. But I do see a 45 degree added to a 30 would definitely work in this case. Now, when I have this, I can now use my formula for cosine right up here that has u plus v. So I'm going to have the cosine of the first, which is 45 degrees, and that is going to be multiplied by the cosine of the second, which is 30 degrees, and from that I'm going to subtract my sine of 45 degrees times my sine of 30 degrees. Working that out for each piece, I know that by my trig chart, or by memorization now, I have radical 2 square root 2, I have square root 3, or radical 3 over 2. From that, I'm going to subtract a square root 2 over 2 and multiplied to a 1/2, which is the sine value of 30. Now, working this problem out further, I see that we have an ability to simplify, getting a radical 6 over 4 minus a radical 2 over 4. Again, I can combine my fractions, common denominator, radical 6 minus radical 2, which could be rewritten, but I don't really suggest this. We could factor out a radical 2 and have a radical 3 minus 1 all over 4. The most simplified or simplistic of these is my square root 6 minus square root 2 all over 4, and I think that's the one I'll choose to use. Now we have a sine of pi over 12, so we're thinking radians. In this case, I need to exchange this 12 out with some form of 6, 4, or 3. And I will take the sine and I will make it a 4 pi over 12. Now if I have 4 pi over 12 and I need 1 pi over 12, I need to subtract from it a 3 pi over 12. So you'll see that the 4 and the 3 will divide very nicely into 12, giving me the following. Sine of pi over 3, and then we also have our pi over 4. Okay, now let's use our trig identity. So let me go back up and remind you that we're using the subtraction this time. So sine, we have a u minus v, So we're going to have sine u cosine v minus the cosine u of cosine v. So how is that going to look for us? In this problem, this means that I will, again, be using this identity here. I will have a sine of pi over 3 times a cosine of pi over 4, and from whence I'm going to subtract a cosine pi over 3 sine pi over 4. Looking for those exact values, the sine of pi over 3 is radical 3 over 2. Then for cosine pi over 4, I have a square root of 2 over 2. From that, I'm going to subtract a 1/2 times a radical 2 over 2. Now, just a quick summary, we're going to see that we have a square root 6 over 4 minus, in this case again, a radical 2 over 4, and we're going to make it a combined fraction of radical 6 minus radical 2 over 4. Now it might seem like we're always supposed to get that for an answer with these problems, but that simply is not the case. If we take a look at this next problem, we will get that same answer. It just happens that's the ones I printed out. But if we look at this, we have to use, or remember, we have to use either our 30, our 45, and our 60 to get this one to work out. I have two choices. I could take sine of 45 degrees and subtract 30 degrees from it. Or I could have chosen to get the 60 involved because he's been kind of lonely up there. 60, and from that I could subtract a 45 degrees. So I've got a couple choices here to use. Now, I'll use this first one, nice and clean. And what I get is I get the sine of 45 degrees. Now that's going to be multiplied by the cosine of 30 degrees. Remember, this would be my u, and this would be my v. And from that, I'm going to subtract a cosine of 45 degrees and a sine of 30 degrees. So I start to make a note to self that I've got one sine of 45, and then I must also have a cosine of 45. I have a cosine of 30 degrees and a sine of 30 degrees. So I'm going to see this reoccurring theme over and over again as we work with these sum and difference formulas. Now, we're going to finish this problem up by making the exact values. And the exact values in this case is radical 2 over 2 times a radical 3 over 2 minus a square root 2 over 2 times a 1/2. Now these are multiplied with a subtraction in between, and that will give us radical 6 minus radical 2 all over 4. So that common theme keeps reoccurring. Let's take a look at tangent 7 pi over 12. Once again, we have this 12 here in which we're going to use some form of our pi over 4, pi over 6, or pi over 3. And in this case, I will rewrite this as tangent, and I'm going to write it as a tangent. Well, momentary lapse in memory. I'm going to use my 4 pi over 12, and to that I'm going to add 3 pi over 12. Because I'm looking to get this 7, and simply a 4 plus a 3 will do that for me. Now this isn't my final form of this identity. I'm going to simplify it and, of course, get my tan pi over 4 plus pi over 3. Now this formula is a little bit more complex. If you take a look at this formula up here, we're going to use the, I think it was subtraction, or addition rather, and we have to look at tan u plus tan v, and that's all going to take place over 1 minus tan u tan v. So we're going to come down here and start to perform that task. So I'm going to have the tangent of pi over 4, that being my u, and I'm going to add to it the tangent of pi over 3, which is my v. Now I'm supposed to subtract, or 1 subtract, and now I'm going to subtract the tan u tan v. So tangent pi over 4 times my tangent pi over 3. Now it's a process of putting in the numbers. For tan pi over 4, I have a value of 1. For tan pi over 3, I'm going to get a value of radical 3. Now in the denominator, I'm going to have a 1 minus, and here I'm going to have really a 1 times a radical 3, which we would normally just write as radical 3. And you can see my dilemma. I have to rationalize this denominator. So I can't just go to an equality. I'm going to need to multiply it by 1. That ever powerful multiplicative identity of 1. My 1 is going to look like the conjugate. And so I have a conjugate pair here in the denominator, and that is going to give me a difference of perfect squares, ridding myself of the middle term, which will eliminate the square root in the denominator. So I'm going to have a 1 minus 3 in the denominator. In the numerator, using my shortcut, I will have a 1 plus a 2 radical 3, and then a square root 3 times the square root 3, or a square root when it's squared is going to cancel, giving me a 3. So what we'll do at this point is put the numbers together, and I see that I have a 4 plus a 2 radical 3, all divided by negative 2. That's not simplified yet. Everything can be divided by negative 2, leaving me negative 2 minus radical 3. And that is our final answer. We'll look at these next couple of problems in video number 2. So thank you, and we'll talk to you soon.